So in this video, we will learn how to make scripts that allow you to change the colors of a material to build this basic bike configurator. And if you want to follow along, you can download the model from Sketchfab. And that's all I have done so far. Downloaded the model, I dropped it into my assets folder in Unity and then into the scene. And that is how we will start now. So let me just clean my scene again so we can start from scratch. I will also create a script again. Well, this is the script if you want to jump ahead. But let's just restart from the beginning and I will explain you step by step. I will just delete the script and we will start right from the beginning. In Needle Engine, when you have your web project, you put your scripts into the source scripts folder if you want to create components that show up in Unity or Blender, for example. So we will just create a new script and we will name it my color selector. And we put .ts at the end because we want to write a TypeScript component. And to create a Needle Engine component, what we need to do is we need to derive from the behavior class. And we write it like this. We export a class and with a name, whatever we want, like my color selector, and make sure it extends from behavior from Needle Engine. And I click tab here to just autocomplete. And you can see the import from Needle Engine has been inserted by VS Code already. And if I save now, the script will be generated in Unity automatically. Like we will get a C# component inside of Unity that we can now attach to our object. Like, yeah. And you can see here in Needle components, you can see my color selector, which is just a generated C# component from our TypeScript file. And that is cool because it means we don't have to switch back and forth between Unity and TypeScript and three.js. We can just write our three.js code and whatever is editable in Unity, we can expose it to the editor. Yeah, so let's attach my color selector. I will remove the old script. My color selector to the sphere that I have in my scene. I can also click the blue open my color selector label here, and it will automatically go to the correct file with my code. So I can continue editing here. So what do we want to do? First of all, I think it makes sense to show you some of our built-in event functions. Like let's make our sphere react to my cursor, to my mouse. So we have like certain on-pointer event methods. And these are very useful. For example, if I know I want to do something when my cursor enters my object, like it starts hovering over my sphere, this method is automatically being called. And the same way around, we also have on-pointer exit, which is when my cursor leaves my object. And I can just, for example, I can just console log here and say hello, enter, and then maybe print the name of my current object. And I can do the same for exiting. Hello, exit. And you can see now when I hover over my object, maybe like that, you can see the console log being printed. So this is working. And what I want is, I want my sphere to scale up when I hover. So what I will do is, I will create a variable and I call it hovered. And this is of type Boolean and it's false by default. And when my cursor enters the object, I will set it to true. And vice versa, when it leaves the object, I will set it back to false. And now we can use another event method that we have, for example, on before render, which is the last event method that is called every frame right before our scene is being rendered. Okay, so in on before render, we want to scale our object. And now maybe you ask, how do we know, or what exactly do we scale? So every component is attached to an object. And we can access the object the component is attached to by going to this game object. And this game object is really the same as a free object 3D. This is the object 3D in the scene. It is the same sphere that we attach it to in Unity. And yeah, that is the three.js mesh, basically. And we can just modify the scale here. I can say if this hovered, then I want to set my scale to maybe 1.1. And otherwise, I want to set it back to 1. And as you can see, well, here's my sphere. And when I hover over it, it scales immediately to 1.1. But this is not really pleasant to look at. Let's just interpolate. Instead of directly setting the scale, we can also use the lerp function. And we can, for example, also pass in a vector here. Make sure it's imported from three.js. And the lerp function takes an alpha value, and we can access that with this context dot time. And now delta time is how long did the last frame take to render. And we can use that and divide it by 0.1, for example, or 0.2. And let's do the same for the scale to 1 again. We just pass in 1 here, and we will save our script. Go to the browser, and voila! Now our sphere is scaling very smoothly. Something else that you might encounter in this scenario is, let's assume our sphere is scaled down in Unity. Like the initial scale is 0.3. And if we save the scene again, you can see it's being exported, and go to our web browser. You see it scales up. It scales up to 1. And that is because our scale value is hard-coded here. To fix that, we can save the scale that we had in the beginning and use start, for example, which is called once for every component. And we can save the start scale in a new variable, in a vector 3 here. And vector 3 is a type from three.js, so we can just import it like that. And now we copy the start scale into that variable, like this start vector, copy this game object scale. Maybe we should rename it, sorry, start scale. And now we can scale to the start scale that we saved, like this start scale. Sorry, it belongs here. And we also want to save like a target scale, like how big should it be when it's scaled up, when we hover over it. So we create another vector and call it hover scale. we will calculate it once here. And what we will do is we copy the start scale and then scale it up by 1.2 once. And now we can use the hover scale when our object is being hovered. And when we now go into the browser, we will see the sphere stays small, and when I hover over it, it just scales up a little bit. That's exactly what we want in this case. So we have basic interaction, and what is still missing is like a click event. Let's go and add that on pointer click. And just to illustrate, we can another way you can display debug information or that something has happened. You can use the show balloon message method, and you can type in any message that you like. For example, hello, object has been clicked. And we save our scene. And when we now click on our object, we see, hello, object has been clicked. Okay, but what we really want to do is, when we click our sphere, we want to change a material. We want to change the color of the frame of our bike. And how can we do that? And we can do that in our script. For example, we have a color field exposed in the editor. This is just a public variable, and it's a type color. And we can just set a default value. We need to add the add serializable decorator in Needle Engine and set the type to color. And what that does is it tells Needle Engine that this field is of type color. Yeah, we will just declare the variable like this. And when we go to Unity now, we will see the color appear. And now we have it. Here's our color input field. For example, we can set that to white in this example. So we have our color now, and when we click our object, we want to set the color of a material. So what we also need is either a reference to the object that we want to change, or we could also directly save a reference to the material that we want to change. So we can create a material property here and say it's a mesh standard material from three.js. And it can be a material or it can be null, because we can have a material assigned in Unity, or we could have forgotten that. And we do also need the serializable, same thing as before. And yeah, let's go back to Unity. Okay, cool. Now we can use, we can pick the object in our scene, go to the metallic material that we want to change. It is here in our project, and we can assign it to our script. And to save this setting to our GLB, we just export again. And now, when we click our object, we can assign the color that we saved here and to the material that we attached. Let's write the code for that. If we have a material, so we just check if this material, we could also write like if this material is not null, then we can set the color. This material color, copy, and this color that we have set in our editor. And when we go now to our browser and we click our sphere, we can see the frame is now white. Cool. And to make this a little more exciting, we can actually, easily just copy the sphere that we have here now a couple of times. and set different colors in our field. Like this, and maybe a fourth one, maybe make it blue, why not? Or pink. Export our scene. And now every sphere sets a different color on our bike. This is pretty nice, I guess. Of course, all the spheres are white right now, which is not really great. I mean, we cannot really see what color we are setting. So one way to do that is assign different materials in the editor that match the color that we are setting. For example, this is the pink one. This is the orange one. So we assign a different material here. Make it orange, and so on. So this is one way we could do that. But you can see it's a little bit tedious because we have to keep track of what color is on the sphere and what color is actually assigned here. So I guess we can do better. And yeah, of course we can. And we could do that like by simply accessing, for example, the material that is currently on our sphere, take the color from that and apply it to the bike. And like, how can we access from our script the color that is currently assigned? Well, that is simple. Let's just remove this color because we don't need it anymore. And get the color from our currently assigned material. And we can do that with accessing the renderer. You can get components on the same object. Like if we want to access the mesh renderer, for example, and access the material on the renderer, we can do it like that. We can get const renderer is equals this game object. And we get the component renderer. This is an imported type from Needle Engine. And the renderer has an array of the materials that are currently assigned to the same object. So it's an easy way to access all of these settings. So if we have a renderer, then we want to take the material. And it's like this renderer shared material. And maybe if you have a Unity background, a lot of these things will sound familiar or feel familiar. And we do that to make it easier for you to start writing TypeScript, because TypeScript is actually really, really similar to C#. It's not exactly the same, but many things will feel familiar. Okay, now we have a material and we will see, okay, this is of type material. And for the sake of this example, we will just assume that all our materials are mesh standard materials. For example, we can do a check to make sure it is of the correct type. We can write if material instance of mesh standard material. And what we can do now is material access the material color. And yeah, this is how you can access the renderer and the materials on the renderer and the color. Okay, now let's just export once more. And now setting the color is actually coming from the materials that we set in Unity. We can create now many more materials on the fly, like this. Just copy the sphere, assign a new material, give it a cool color like some green or like that. Export to the web. And here it is, new color. I hope this gives you a good first introduction of how to access different properties in Needle Engine, how to write code that reacts to input without having to deal with pointers and mouse cursors. And I think one thing to note here is all of these methods, they work across the board. They work with touch, with your WebXR inputs, with your controllers, with hand input. You don't have to worry about any of that. You don't have to deal with any of that yourself. You can just rely on Needle Engine to make sure on pointer enter is called, on pointer exit is called, on pointer click is called. Whatever input system your user is currently using, or if they are in WebXR or just on a desktop PC. Thanks for watching, and let me know in the comments if you have any questions or wishes that you want to know more about. Yeah, bye.